Hi, I'm Chris Devlin. I'm a product manager at Festool.
Hi, I'm Rick Bush, and I'm the product marketing manager here at Festool.
The purpose of this video series inside Festool is over the years, well, I should say I've been with Festool now for, I guess, almost 9 years. Rick, how long have you been here?
Double that?
Yeah, double that. So we've been around for a while. I worked at Festool dealer before Festool, and I think myself included, a lot of us always wonder what is inside the machines. We know the machines work really well, and a lot of people wonder, what goes into the machine, a little bit of that under the hood look. And so the purpose of this video series is, we want to try to get this information to you guys so you can understand what's inside the machines. And so as we kind of go through this process and learn how to make these videos better, of course, we also want feedback on what do you want to see, what types of machines do you want to see, what are you curious in, is it testing, is it specific components, etc. So we can try to figure out what that information is from our colleagues in Germany and share it with you so you can understand how do your machines work, why are they the way they are. And so that's kind of the purpose of this video and this new series that we're doing, and hopefully it gets better with time.
Yeah, and to help give a little frame to what we're about to talk about, we want to talk a little bit about our history, the innovation we've seen in our cordless drill drivers, and the small collection I have in front of me. This doesn't exhaustively cover all the different variations or voltages or even types we've had, but a pretty good representative here. I start off with the oldest one in the collection. This is actually was one of the last ones built in 2004. We started what we called the CDD, and this drill has a rather large battery. Gave it a kind of unique form factor, and that form factor stayed with us for a while and still have it today, actually. So we went from the CDD, which was a 12 volt. We actually had a 9.6 as well, but 12 volt. Then we went to the C12. And this was huge when we introduced this. It was 2005 in Europe, 2006 in the US. And at that time, to have a brushless motor and a cordless drill driver available to the mass market was unique. We were first movers here. But we still had a nickel cadmium battery. We had nickel metal hydride. Lithium ion had become all the rage, even though it wasn't quite in its maturity yet for cordless power tool usage. So we see that grow and change throughout the years to the latest version we had here, which is C12 with a lithium ion battery. We still see this platform and this design, what we call the C-style, today in the C18. Likewise, we also had what we call the T-style. We'll see a lot of T-style stuff today. This was the TDD. This also dates back to the same era or generation as the CDD. And it has a rather large motor area here. This was not a brushless motor at the time. It's still a large brushed motor. And the nickel, this one is a nickel cadmium battery pack, 2 amp hour. We also see the T-style and what we had the TDK series, so TDK 12, TDK 15.6. So we were really pushing it there. We were up to 15.6 volts from 12. And even here we have the last generation made of the T15. So today we're going to mostly talk about 18 volt, but we wanted to talk a little bit about where do some of these design concepts come from, and also what makes up these drills in particular. And what I also want to focus on here is the compatibility. Yes, batteries aren't fully compatible over the generations. The newer drills do work on lithium ion. The older ones didn't even know what lithium ion was, so they're not set up for that. But when we talk about some of the accessories that are available, here we still have, and we started with this removable chuck concept. So a lot of you have seen that who are familiar with our brand and our products. And we had the removable chuck, we had the Centratec chuck. We'll talk a little bit more about Centratec in a little bit here, which made the drill overall more compact, very lightweight, very remarkable at its time. Nobody else was doing this. We also had the ability to put on a right angle attachment, which you could position in 16 different places all around. And you could use the same keyless chuck. You could use the quick changing chuck with a Centratec on here. And we also had this little guy I really like called the eccentric. Eccentric would take that bit that would normally be in line with the driver and put it off to the side. So this was a very, very unique in the market move for us to have this compatibility. But if you look at these chucks that we have here, it works on all of these drill bodies starting, well, our first generation we're showing here, this is again from 2004, so for Festool North America, that was kind of first gen. And these same chucks work on the drills we are selling today.
Yeah, which is remarkable.
Yep. And even so, and we'll get to these a little bit more in detail later, I can take the latest generation, which is quite updated, of this right angle, also for the eccentric, and it's still going to interface to this old CDD drill. So that's pretty cool. If you still have one, you can still use today's accessories on it, which is outstanding. But throughout the time we saw the battery technology change. We made that huge update with the brushless motor in the C12. Well, brushless is definitely going to be the path forward for our cordless drills. And we even have a nice little cutaway here of the C12, so you can kind of see what's going on here. It was quite remarkable, again, for its time, because nobody else is really doing this. Today, everything has a brushless motor, it seems. So in this cutaway, you can see this is an old nickel cadmium battery pack here. You have the fully integrated control board here, where the switch is actually integrated into the electronic control board. This is your brushless motor, and this is your clutch control, which at that time was electromechanical. If I go back in time,
just mechanical.
Purely mechanical, right? Then we went to electrical mechanical, and our latest generation are fully electronic. So quite a cool evolution there. And also you can see this is that part of that system that was holding the chucks on. It doesn't change throughout the generation.
And that's what was fascinating, Rick. We were looking at today. If you look at this part right here, that's machined in almost the exact same way. And what are these, 18 years apart?
Oh,
basically?
At least, yeah.
At least,
definitely.
yeah.
So let's explore a little bit more about the electronics and the switch and what makes that unique.
Absolutely. So if you think about it, you're using whether it's a drill or an impact driver, the one component on the machine which you're going to interface with basically every time you use it is going to be the trigger. And obviously with the trigger you also have the electronic. This is I would say, relatively common switch. It's something you can buy commercially. It's on the market. A lot of competitors use switches like this. One thing Festool has done, really, even back, you can see here, it's a similar setup here. They have been making their own switches, or Festool has been making our own switches and our own electronics for many, many years. And obviously there's advantages there in how we design them, quality control, etc. But it also allows us to do some unique things that aren't easily available on the market to go purchase. One of those things would be the fact that most switches are mechanical. So when I pull, this switch is actually a mechanical action inside which turns the drill on and off, whereas the Festool switch is using a sensor. So it's a magnetic sensor inside, and that's actually what sends the signal to the motor. And the interesting thing about that, and it's easiest to demonstrate just by pulling the trigger, is we get what's called a very long trigger pull. So I have really an infinite range of adjustability here in how I can get power out of the machine, the RPMs that I can generate by having that. Another
thing, it really
thing
allows you to finesse
control,
and
gives
really
you the finesse.
Drive that screw to just the right setting so you don't overdrive it.
Well, and it's interesting, Rick, when we were in the process of developing the impact driver, which one of my first projects when I first took this role was doing the market research for this. And an impact driver, we all know them, we've all used them. Mm-hmm. One of the comments we got from the test users at the time was this long trigger pull, and how if you are doing cabinetry or for whatever reason putting on hinges or any other kind of finesse application, that long trigger pull allows you to kind of have a gentle touch and not strip out the screw. So there are some real benefits to it. One other thing I want to point out, if you look at the control board here, these electronics are all potted, and what does that mean and what's the difference? Well, typically what you would see is a lacquered control board, and the lacquer is just simply not as durable. The potted gives you dust resistance, moisture resistance, and it provides for a very stable platform for all these electronic components to be mounted to. And at the end of the day, what does this all mean? Well, this switch is rated for 1 million cycles, and that's much, much longer than you're going to get from a mechanical switch. So there's virtually no wear. And this is why even some of the machines Rick has here, which are your personal machines, these are going on 15 sometimes.
My museum.
Yeah, your museum. They still work, right?
Yeah.
And I think most of us realize that, if our switch fails, we might assume the whole drill is just shot, even if it's just the switch. So very critical component. We talked about the controllability, in-house production of the switch. Festool's been building these switches now for many, many years. So I think that's a neat thing. You can see it inside here in a little bit more detail. You can see in here more detail the switches and how those are done as well.
So the brushless motor technology, again, you hear it all over the place. I've seen it even on like household vacuums that you can buy. It's become very, very commonplace. Does that mean all brushless motors are created equal? Absolutely not. It just means the technology has become more acceptable, and people understand there's a benefit to this. And those benefits, most people should be familiar with, but we'll just iterate them here, is longer battery service life. So in terms of the runtime of a battery is extended because the motor is much more efficient. The motors, like these old ones, these brush motors, they may have only been like 30% efficient, which is pretty low. It's a measurement of how much juice going from the battery to basically...
It makes it to the end, right?
It makes it to the end. It's going to turn the drill bit or run a screw. The brushless motors are 90% or greater efficiency. So you're getting much more use out of the battery pack. They're also longer lasting. So we get a million
absolutely.
screws, a million screw cycles out of our switch. Well, okay, that's wonderful, but if your motor isn't capable of going a million cycles, it doesn't matter. So you want these things to be balanced in a way. You don't want a switch that's going to outlast a motor or a motor that outlasts the switch. So that's all balanced, and the motors really don't have very many wear parts. They don't have a lot of friction points. We have a whole article on how the commutated motor works, so we won't go into detail here, but it does allow for longer run times, longer battery life, longer serviceability. If even I go back into the collection here, I have this TDK 15 that had user serviceable brushes.
Yeah, which is interesting.
Yeah. So if you've ever seen these little screw caps on the back of a tool, and some of them still have it today, that's where you change out the brushes when they expire. So yeah, overall you're going to find brushless in a lot of products today, but the important thing is how we address it. And for us, it's not just all those benefits, but also the variability. We can have all these different kind of configurations based on what the tool's supposed to do. Yep. We don't stick the same motor. If you look at this one, you see this impact driver has a different motor than the drill driver. If we take apart our hammer drill, you're going to see a different motor, or our cordless jigsaws.
I think ultimately what you're getting to is design flexibility. So
yes.
the brushless motors give you much more design flexibility. Mm-hmm. You know, you'll notice on this one, this is maybe the most extreme example. You see how long and big that motor is.
Yeah.
Now on
a bit.
on a miter saw, we might not care that much because it's somewhat stationary. It's not hanging on your tool belt all day long. But obviously on an impact driver, on a drill driver, if we can get shorter overall length, if we can get more compact designs, this has big benefits for us. And so I think that's also another key element to the brushless motors, is just that design flexibility and overall compactness as compared to the brush motors.
Absolutely. So next we're going to take a look at the full range of attachments that we have in front of us today. And I already introduced you to a couple of them. We saw the right angle earlier. We saw the eccentric earlier. Yes, we have updated versions. Chris is going to talk about those a little bit more. But I also want to bring your attention to, we have a couple other attachments here that you don't normally see or talk about very much, but this one's for drywall. So this is a depth stop chuck. It's got these nice little clicks. Each click is 1/10 of a millimeter, 256th of an inch. So you get really precise driving of the screws. It has a quick change out top, so you can change out the bit. But my point here is, again, this is a newer product. It's been in the last maybe 5-10 years. Going back to an 18-year-old drill, slaps right on there. So the compatibility is still there, the integration. Another depth stop chuck looks quite different. Looks almost like a regular keyless chuck, but it's also set up for depth stop. It also features that nice little, here, I'll put it on. I don't know if it'll go on the old cutaway here, but here we go. Here, again, I get in there. Each little click, 1/10 of a millimeter, so that's pretty cool. Actually, this one is designed for using with screws that have large washers, like if you're doing like a metal sheathing of a roof. It allows clearance for that. It has this rubber bumper here. I used it to drive deck screws. Mm-hmm. It worked really great. You know, my entire field of screws is all the same depth, and it's very easy to adjust, very easy to change out the tip and bit. And again, yes, going back in time, it'll work on this old CDD. And the last one in this little lineup is a little socket adapter. Again, this is going to pop on to that same interface that we saw throughout the generations, even on our cutaway version here. And this one will accept 3/8, yes, really 3/8 socket. So here's just a regular old socket, pop it on there, and now you've got a true driver with this setup. So the coolest thing about these attachments isn't just their function. I mean, that's what it's doing for you, right? Mm-hmm. But for us, we kind of geek out over the build factor. They are really robust. They are durable. They are long lasting. When we do demonstrations and we drop them on the floor, usually by accident, I always say, well, you know, they're very tough tools, mm-hmm. right? But let's take a look a little bit at what's going on inside to show us what really is happening here. Absolutely, and we're going to take a look specifically at these. So this, as Rick mentioned, which really wasn't even the original. We had another metal version of this chuck before this, which didn't have this special coating on it, and I guess just within the last year that we have switched over and, you know, upgraded this to a new and improved version. You'll see why here in a second. And you know, I think like most people look at it at first, you think, okay, it's plastic, is that better or worse? Mm-hmm. And so we said, well, let's take it apart, let's look at it and see how this thing is built. So I've already got it somewhat taken apart already. I've got the screws out, so I'll just kind of do this in order. So you've got this first piece here, little ring, pretty well made. Then you pull out this next piece, and this is really interesting. Obviously machined, very well done.
Then we'll take off this next ring. This is just a little plastic collar. And there are 3 springs inside, so we'll take those guys out. And this is where it really gets interesting. So there's a spring in here, and I'll show you when we're done what that spring is doing. So let's just pull that spring off of here. And now we should be able to take the entire housing apart. So take this housing apart, and now as you look inside of here, you can see that some pretty awesome stuff going on here.
A lot of pink goo.
That's right, a lot of pink goo, some grease in there. But what's really interesting, you got 2 large bearings. They're matched in size here, and then you've also got 2 rather large gears. And I think what I will do, just to illustrate this, is if I insert this into here, you can actually see the gear ratio there. So it is a true 1-to-1 gear ratio. And
what does that mean, 1-to-1 gear ratio?
Well, essentially what you're going to get is you're going to get a perfect transmission of the RPMs and the power from this axis into the right angle or the other axis that you're trying to drive. So whether you're drilling a hole, could be driving a screw, doing a number of different things, and there's no difference in that transmission in either power or RPM as we turn the corner. And yeah, for me it was really interesting just to see how well this is constructed. You can kind of see the other side here, and I think both you and I, when we looked at this, you know, yes, it is a plastic housing, but you can see a ton of webbing and reinforcement in there, and it's a very robust piece altogether. So very interesting.
No deflection. I mean, you squeeze it and you pound it on things.
No, absolutely no deflection. And I guess in total here, you know, we've got the gears, we've got a couple bearings, we've got these other components here.
These precision machine outputs. I mean, this output, I like to call it a PTO. I don't think that's exactly right.
It's probably not the right term.
I'm thinking of agricultural tractors here. But the cool thing is that anytime you're running a bit in this, it just pops right in there, and this bit is going to run true. It's not going to wobble. It doesn't carry on, and you get that perfect transmission of power.
Absolutely. Well, and I think that's something we didn't touch on yet, but with the Centrotech chuck, and these are not so easy to get apart. But if you could see the inner part of this, the metal part, essentially what is happening is the end of your driver, whether it's on this, let's just use this as an example, it's going into this part of the drill even when the chuck is on. So it's actually passing through. This is hollow, so it's passing through here like so, and it's actually seating directly into this. And inside of here there's 2 sets of ball bearings, so I guess in total 6 little bearings, and 3 of those are sitting in this little groove right here, and then the other 3 are sitting in this little groove right here. So you've got 3 there, 3 here, and now what's happening is this drill bit, driver bit, whatever you happen to be using, is in the end of the drill, but then also supported out here. So you get less run out, as Rick mentioned, better transmission of power because you're fully seated in here. Whereas if you have something like this on here, you know, your bit is just hanging in the end of this, as opposed to being supported fully back into the machine.
So if you take a normal chuck and what it weighs,
versus
and you put that on here, and then if that Centrotech chuck was just an add-on piece, oh wow, it gets pretty long, right?
Absolutely.
And not to mention all that weight, it's really bulky. So we got rid of the entire length of this chuck, and we're coupling directly on. And again, like you said, that's popping right in there, but otherwise it would, well, normally fall right up with that magnet. It's doing a good job today. This just really locks it in there so it doesn't come off, and you're not losing it.
I want to mention one other thing, Rick, with these new chucks. So with the old chucks, and Rick's put these on and off several times, like he mentioned, 16 positions that you can put these on around the horn. So you'd put it on, lock this collar, now you're on. And the way it's locking on is it's this little ramp right here. So you can see how that ramp gets thicker as you turn, I guess it's right here, this ring right here. And there's little grabbers in here that pull it on tight. Same concept with the new chucks. What's different, and what I find absolutely fascinating, and we can all see together now once this is apart, somewhat how this is working. But instead of having to take it off to reposition it, all I have to do is turn this, and I can go all the way around. I can go in either direction, and that's true with the right angle chuck. It's also true with the new eccentric chuck. And that, you know, that's maybe not seem like a big deal, but if you have, for example, a big drill bit chucked on here and you're up in a joist bay or something, and you just need to pivot that angle ever so slightly, it is pretty handy.
Well, you just went from what was a 2-hand operation. I loosen with one and move with the other. It's strictly one-handed. So if I am working up somewhere, all you have to do is twist that ring.
Exactly.
Yeah, it's not the fumbling that I may have to do here.
Absolutely. Well, I think that that covers the chucks that we wanted to talk about. So I guess we can bring this one home.
Yeah, so that's, again, just an overall kind of a peek inside. If you've never taken apart your drill before, we got some great examples of what you see in there. It's all components. It's all really well nestled in there and protected. So yeah, we say give you a 3-year warranty on these tools. That includes wear and tear. So if you do take a drop, it's really well protected against it. If you're in a particularly dusty environment, it's protected against it. Same thing with moisture. But the worst case scenario, something does go wrong with it, even with the batteries or the charger, we're going to take care of it in that 3-year period. So again, just a little sneak on the inside, and stay tuned for more.
2 things I want to mention. One thing is, I think my takeaway from kind of looking at all this is, if I had to summarize the Festool approach, especially with drills, but I think this translates to a lot of machines, it's a holistic approach, you know, and like Rick mentioned with the motors, or whether it's the gearing or the battery, you know, if you have any component which is not up to par, then that's your weak link, right? And that's your limiting factor. So I think as you see the chucks and the compatibility and all this, it seems like there's a holistic thought process and design approach to this. So I think that's the last thing I had.
Thanks for watching.
Thank you.